This is my video about the circulatory system.
We're going to be talking about the circulatory system, its functions, and the hormones that regulate blood pressure. The circulatory system consists of three components: the blood, which is a connective tissue, the vessels, which are muscle tissues, specifically smooth muscle, and the heart, which has muscle tissues, specifically cardiac. It works together with three other systems for homeostasis in the body: the endocrine system for the hormones, the digestive system for the nutrients, and the skeletal system for the production of blood cells. One of the key components of the circulatory system is the heart. This is a muscular organ that pumps blood through the blood vessels of the circulatory system. The heart has arteries and veins. Arteries are the blood vessels that carry blood away from the heart, and veins are vessels that carry blood to the heart. Oxygenated blood first leaves the heart from the left ventricle into the aorta. The aorta then divides into medium and small arteries. Then it divides into arterioles. Capillaries are where arterioles and venules meet. Venules then fuse together to form veins, and these veins fuse together to form the superior and inferior vena cava. Since the arteries are receiving the pumped blood from the heart, there is significantly larger pressure in the arteries than in the veins. If we were to rate the blood vessels by their amount of pressure, the aorta would be 10 and the superior and inferior vena cavas would be 1. There is a general equation that explains the relationship between blood pressure, blood flow, and resistance. Delta P is equal to Q times R, where delta P is the change in pressure, Q is the blood flow, and R is the resistance. Blood flow is defined as stroke volume times heart rate. With this in mind, we can infer that the higher the heart rate and the higher the blood volume, the higher the blood flow. Resistance is dependent on the diameter of the blood vessel. If there is a smaller diameter, which occurs in vasoconstriction, there will be higher blood pressure. Subsequently, if there is a larger diameter, which occurs in vasodilation, there will be lower blood pressure. But how is this blood pressure regulated? Let us first look at the hormones that are responsible for increasing and decreasing the blood pressure. The hormones that increase blood pressure include antidiuretic hormone or ADH, aldosterone, angiotensin II, and epinephrine. The hormone that decreases blood pressure is atrial natriuretic peptide. These hormones mainly act on the kidney. It is important to understand how the body regulates blood pressure, as too high blood pressure can cause heart attack, aneurysm, or stroke, whereas too low blood pressure can cause nausea, dehydration, or organ failure. ADH is produced by the hypothalamus and stored in the posterior pituitary gland. It is responsible for water retention and reabsorption. It affects the kidneys, specifically the collecting duct. Higher concentration of water means a higher blood volume, which means a higher blood pressure. Aldosterone is a hormone produced in the adrenal cortex. It affects the distal tubule as well as the collecting duct of the kidney. It promotes sodium reabsorption. Higher concentrations in sodium means a higher blood volume, which means a higher blood pressure. Angiotensinogen is released from the liver. It reacts with the enzyme renin to form angiotensin I. This reacts with ACE to produce angiotensin II. Angiotensin II causes vasoconstriction, which increases blood pressure. It also triggers hypertrophy and thirst, and increasing the blood pressure. Epinephrine is produced in the adrenal medulla. It causes vasoconstriction as well as increases the heart rate, which both increase the blood pressure. When high blood pressure is detected by receptors in the heart, it stimulates atrial myocytes to produce atrial natriuretic peptide. This causes vasodilation, which decreases the blood pressure, as well as decrease the enzyme renin so that angiotensinogen can no longer form into angiotensin II. This is to decrease the blood pressure. Here is a detailed table about the hormones we have just discussed. You may pause the video to learn more about them. That concludes the lesson on the circulatory system. Thank you for listening.